carefully, but steady, 3.6, 8, and 9. Okay, so let's start with the daily concept check. If a function has a slant asymptote and no horizontal, can you give me an example of these degrees? A rational function that has a slant asymptote. Give me an example of these degrees.
3/2.
Exactly. In other words, what you are really saying is the degree of the numerator has to be exactly by 1 unit larger than the degree of the denominator. If somebody would have said 5 and 2, I would have said that's not possible because the difference in degree is not 1. Degree 5 minus degree 2 is degree 3, not 1. But degree 3 minus degree 2 is 1. Awesome. Thank you. Awesome. Thank you. Okay, so we have this function on a closed interval, point A, point B, point C. Can anyone tell us what is point B?
Relative and absolute max.
Excellent. Relative and absolute max. Awesome. Can anyone tell us what is point C? Great job. Thank you.
Absolute min?
Excellent. Can it be a relative?
No.
No, because it's at the endpoint of the interval and the function does not exist on this side. Awesome. Can anyone, great job. Can anyone tell us what is A?
Nothing.
Exactly. It cannot be relative. It cannot be absolute max because there is already one that is higher than it. We can have, by the way, we can have two absolute max, one here and one here because they are at the same level. So we will have a max at x equals 1 and a max at x equals 5. And they're all both the same. Let's say y equals 10. We can have two absolute max. Well, actually, it's still 1 because the maximum is 10. But they can exist in different spots, in different places, for different x values. So, because this is nothing because there is a higher point, and it's nothing because there is a lower point that we already identify as absolute max and absolute min. Absolute min and absolute max. Awesome. Very good. Well done. The floor is open for any questions. Anything you want to work on, any questions you may have, anything.
Can I see the homework problem number 30 on section 3.4?
Sure. What was the function f of x equals?
If I remember correctly, it was equals x minus 4 over 3 to the x third, and then with a range of 0 to infinity.
This is domain 0 to infinity. Very good. We had a similar example. I was just looking through the notes. We had a similar example with the interval 0 infinity, roughly. So the same idea. So we are given 0 to infinity. So this is f prime, and this is f of x. Of course, you cannot put anything under this, and you cannot put anything under this, because we're not allowed, according to the domain that we are given, we're not allowed to put 0 in. And of course, infinity is a symbol. So we have to find f prime of x, which will be 1 minus 4x squared. And we have to look at when equals 0 or undefined. It's a polynomial. It cannot be undefined. And for this, 1 minus 4x squared equals 0. It's 1 equals 4x squared, and we have to take the square root. Remember, two solutions because the degree is 2. So when we take the square root, we get 1 equals plus or minus 2x, or the other way around. It doesn't matter. So x equals plus or minus 1/2. But negative 1/2 is not in the given domain, so I cannot put it in. But I can only put in 1/2, and I have 0. And when I study the sign, I can put in here, for studying the sign, I can put in 0, so it's positive and then negative. So this is definitely the absolute max. And I have to find it. I have to plug in 1/2 in here. So f of 1/2 will be, how much did you get? 1/2 minus 4/3 times 1/8. It's 1 and 2. So 1/2 minus 1/6. So I'm getting 2/6, which is 1/3. Any questions?
Okay.
That's all you needed to do. Any questions?
Where I made the mistake was I dropped the x value, and instead of putting 1, I just dropped it completely.
For some reason, I couldn't hear you. Maybe it's my computer, but can you speak up?
Yeah, I said where I made the mistake was that when finding the derivative of the function f prime, instead of putting 1 minus, I just put negative 4 squared, and then that messed me up.
That's okay. As long as now you know, that's fine. No problem. Very good. Other questions for me? Anything? Is there anything else that you are working on and you need help with? Anything else from any section, anywhere, anything? Okay then, so we're moving on to section 3.6. 3.6 deals with something called differentials. And linear approximation. There is also something called marginals. And let's start with this because this is the simplest thing to start with from all three. When we're asked to find the marginal cost, we're asked to find C prime. If we're asked to find marginal profit, we're asked to find P prime. When we're asked to find my maximum revenue, marginal revenue, we're really asked to find R prime of X. That's it. Now I would like to move on to differentials. Maybe it will be easier if we move on to the linear approximation next. Okay, so we have a function, our best friend, f of x. We have a point. Can anyone give us a point? Any point. Just make up one. Any point you like. Anyone, please give us a point. David, will you give us a point? Okay, Ezra, will you give us a point?
1/4.
That's awesome. That's it. Perfect. Great job. So here is, I'm going to draw the tangent line to that point. Here's the tangent line. I'm going to call this point P. So I'm going to say tangent at P. Can anyone tell us how to find the slope of this line? Anyone? We discussed this at least 3 or 4 times so far. Please, I'm begging you, try. It's okay if you're wrong.
The derivative of the function for x equals 1.
Exactly. So this is f prime of 1. Very good. Awesome. Knowing this, can I determine the equation of the line? Yes. By writing y minus y1 equals the slope times x minus x1. This, and I move forward to the other side. You can say, well, you don't have f prime. True, because I did not come up with a function. But you will give me a function. Give me a function, and we can finalize it with numerical, an example. So y equals then f prime of 1 times x minus 1, and of course plus 4. This is the equation of the tangent line. Equation of tangent line at P. And you can say, what's the big deal? I'll explain in a minute. So now make up a function. Make sure that you give us a point that is on this function that you will give us. And then I'll explain what this represents in addition to the equation of the tangent line at P. So, can anyone give us a function? And then a point. You can pick from the book, you can just make one up, whatever you decide. Anyone, please? Can anyone give us a function? I realize that I don't have the book open in the background, so that's what I'm doing. So can anyone give us a function and a point, please? Anyone, please? Anyone? A function, please?
X squared plus 3.
Awesome. And can anyone give us a point? So choose x and determine the corresponding y. What x would you like to use?
Five.
5. Very good. And then what would be the y value then? I can't. I have to plug it in. I can't choose.
3.
Say it again.
3.
I can't. I have to plug it in. This
53.
number is f of 5. I cannot guess a number here. If I pick x, I have to determine y. Otherwise, this point is not going to be on the graph.
$53.
Yes, 53 indeed. It's the only number that works. 5 squared is 25. 25 times 2 is 50. 50 plus 3 is 53. Awesome. Great job. So then can anyone again tell us how to determine the slope of the tangent line at 5, 53? How do I write that? Again, how do I find the slope? Anyone, please? What do I have to find first? To find the slope of the tangent line at this point.
The function.
Yes, let's find f prime, of course. What do I get?
4x.
4x indeed. Then what do I do to find the slope? Awesome.
Four times 5.
Yes, f prime of 5, very good, which is 20. Excellent. So the slope is 20. Great job. Thank you. So now can I find the equation? Yes. Y minus 53 equals 20 times x minus 5. Great job. Okay, moving on. And that's my page 3. Good. So y equals 20 times x is 20x. 20 times -5 is -100 plus 53. It was negative here. I move it to the other side and it's positive. Very good. So then y equals 20x minus 47. Now what this is called, and it's labeled L of x equals 20x minus 47. This is the linearization of function f of x equals the one that you just made up for us, near 5. And you can say, what are you talking about? What is this? What is this linearization? So the linearization represents, so this is our function. This was the equation of the tangent or the linearization. L of x equals 20x minus 47, and f of x was, according to you, 2x squared plus 3. This function, which you see it's linear, of course, it's a line, it's the equation of the tangent line or the linearization. This function, the line, can approximate the actual function very close to left and right of 5. What I'm saying is, if I want to determine the value of the function at 4.9, I can go ahead and put it in the calculator, but it will be very, very close to L of 4.9, because 4.9 is very close to 5. Also, f of 5.01 will also be very, very close to L of 5.01. Which of the two I prefer to work with? Of course, with the line, if the approximation is close. Well, if it deals with human life, I don't want to approximate anything. But if it deals with how much these markers are filled in, I prefer to calculate using the line and not the function. The error will be minimal. Minimal. And I can show you, we can plug it in the calculator and you'll see the error is minor. So that's all about linear approximation or linearization. So the linearization is L of x. The linear approximation is exactly what you see here. F of x is approximately L of x, which is 20x minus 47 for the problem we came up with. They are the same. The linear approximation is written like this. The function is approximately the line by values very close to 5 in our case. And the linearization is, in other words, just the function, the linear function that is the equation of the tangent line. I think we should stop for a second and choose some problems. Let me open the book. I'm almost there. Okay. And this is in 3.6. And the page is 341. And this is chapter 3. And I'm going to say 3.6. Just the multimedia library.